Number 14, solve the following equations. So all those are about logarithm expression. So we have to look at that closely. So we know that, for example, the A part, log base 4 of x equal to a half. We know that logarithm expression is related to the exponential expression. How they are related? So 4 down here will be the base of the exponential expression. And a half will become the power of the exponential expression. What is x here? X is the result of the exponential expression. So if you know that, you can rewrite this as an exponential equation. So x is the result, 4 is the base, half is the power. So you can rewrite the logarithm equation as this one here. And basically, this and that, they are the same. But this one is much easier. 4 raised to the power of half. We know how to deal with that. And if we know that, we will know your x value immediately. So that will become square root of 4, which is 2. That's part A. For part B, we can use very similar strategy. X will become, here, base is 2, power is this -1. So 2 to the power of -1, which is 1 over 2 to the power of 1, which is just 2 here. That's part B. Part C, we use very similar strategy. Log x equal to 6. Where's the base for this one? We know that if we don't write a base here, that means the base is 10. So we can write x equal to base 10 raised to the power of 6. Again, here this number. So that means 6 of the 10s multiplied together. So 1, 2, 3, 4, 5, 6. And this will be 1,000,000. So basically, each time you multiply by 10, you add a 0 to your result. So you have 6 of the 10s, so 6 of the zeros. 1, 2, 3, 4, 5, 6. So basically, that's your answer for part C. Okay, number 15. Find the inverse of the following function. So part A, f of x is log x. So if they don't show you the base, that means the base is 10. So we know that the logarithm function and the exponential function, they are the inverse function for each other. So if the original function is logarithm function, we know that the inverse should be the exponential function with the same base. As we said, the base is 10 for this log. So for the exponential function, the base is 10 raised to the power of x. So that's the inverse function for part A. Part B is very similar. If the original function is exponential function, the inverse function will be the logarithm function of the same base. So f inverse of x is log base 6 of x. That's part B. Part C, the function is a linear function. We want to know what is the inverse function, you have to actually calculate that. So what is the steps? First, we don't want to use h of x, we want to use y. So that will become y equal to minus 3x plus 1. Then we want to solve for x. So minus 1 on both sides. So on the left, that will become y minus 1. And on the right, it will be minus 3x. Then divide by minus 3 on both sides. So y minus 1 divided by minus 3 will become x. So now we will finish solving for x. Then we want to use, we want to change x to y and change y to x. So that's the next step in order to get the inverse function. So that will become this equation here. And again, we don't want to use y. We will use h inverse of x instead. So if we rewrite that, that will become h inverse of x, which is exactly the same as y here. That will be minus x plus 1 divided by 3. Number 16. Write the following as a single logarithm with a coefficient of 1. So for part A, so for such kind of question, the very first step is dealing with this coefficient in the front of your log. We don't like that. We want the coefficient to be 1. So how to deal with this 3 here? It will be the power inside of your log. So that's what this step is doing. So the 3 will become the power 3 inside, and this 2 will become the square inside. Then we want to simplify that a little bit. So for something raised to the power and raised to another power, we will just multiply those two powers. So that x have the power of 4 multiplied by 3. And for the second term, if you have something raised to the power, which is a product inside, you want to give this power to each one of them. So 3 get the square, x get the square 2. And for the next step, 4 times 3 is 12, so x have the power of 12. And 3 squared is 9, and we want to copy this x squared here. So here we have the log, but in front of the log that the coefficient is 1. So that's great. We are ready to go to the next step. So for the subtraction of two logs, we want to put that into a single log, and inside will be a quotient. So inside will be x to the power 12 divided by this 9 times x squared. That's already a single log, and if we look inside, we want to further simplify that because we see exponential expression with the same base up and down here. So the quotient will become the subtraction of the powers. So that's x raised to the power of 12 minus this power of 2, which is power of 10. So that would be your final answer. Single logarithm and nothing else to simplify. That's part A. Part B, very similar. First, deal with the coefficient in the front. That will become the power inside. So that will become the power for each one of those things inside because it's a product. So 2 squared, x squared, get another square. For this 3 again, you want to give this power to each term inside. So 2 cube and 6 to the power 6 outside cube. Simplify that. 2 squared is 4, x squared outside square, so that's basically the power of 2 times 2, which is 4. And for the second term, 2 cubed is 8. X raised to the power of 6 times 3, which is 18. So here, each of the log have coefficient of 1. So if they are added together, we want to put that in a single log. What we do is multiply the things inside the log. So that will become 4x to the power of 4 times 8 to the power of 8 times x to the power of 18. And we'll rearrange that, put the numbers together, 4 times 8, and put the exponential expression together, x to the power of 4 plus 18. So that will become 4 times 8 is 32, and x raised to the power of 4 times 18, which is 22. So that's your final answer for part B. Part C, ln. So that's another log of base e. That's a simplified version to write log base of e. So very similarly, we want to first deal with the coefficient in the front. There's 2, 2, and 4. That will become the power inside. So we give the power to each one of the term inside. So for this one and also that one too. Then we want to deal with the addition of those logarithms. We want to put that into a single log, so what's inside, we will multiply them together. So 5 times x cubed will multiply this x squared. And then multiply this term. If we simplify that a little bit, so 3 squared is 9. So we multiply 9 times z squared. And we will further simplify upper part and then turn the subtraction into the quotient inside. So we will do that in one step. If you are not very familiar with the process, you can do it slowly and have one more step here. So upper here is just simplified what's inside this bracket. So 5 times 9 is 45. X to the power of 3 plus 2, which is power of 5. We copy z squared here. And down here will be this subtraction of log. So y to the power of 4, z to the power of 4. So that's already a single logarithm. Let's further see, is there anything we could simplify? Up and down here we can see z to the power of 2 and z to the power of 4. We can further simplify that. So for the quotient, if we want to use that to write a single exponential expression, what we do is subtract the power. So for the z, the power is 2 minus 4. That is minus 2. But we don't really like negative power. We want to change that to positive power. So that will become the reciprocal of that. So z to the power of 2 will be down here. And we copy everything else as a final result. So that's for part C.